So for number 8, letter A, we need to find the critical numbers of the function and then identify the intervals of increasing and decreasing by using the first derivative test. So our function here is x squared times e to the minus 3x. So in order to find the critical numbers, we need to take the derivative, and in order to do the derivative of this function, we need to do product rule. So we're going to do f prime of x. Again, we have to do product rule, so our derivative is going to be 2x e to the minus 3x plus the other way around of doing the derivatives. So we get minus 3 e to the minus 3x. That's our derivative there because of chain rule, times x squared. So this is our derivative, and now let's see what we can do. We can factor out an x and an e to the minus 3x. That's common to both of the terms there. So what we have left is in the first term we have 2, and in the second term we have a minus 3x. Because we took out the e to the minus 3x, and we took out one of these x's, so there's still an x left, and we have the minus 3 here. So this is our derivative in fully factored form, and we're ready to answer the question. So where are our critical numbers, and what's the intervals of increase or decrease? So the critical numbers are where this function is 0 or undefined. So let's write this as a fraction since we have an e to the minus power here. This is going to look like x times 2 minus 3x all over e to the 3x. So where is this 0 or undefined? Well, it would be 0 if the top was equal to 0. If the top is equal to 0, that means x could be 0, because we just have x here. Or x could be 2/3. Because if x was 2/3, that would make this part in parentheses equal to 0. It could be undefined whenever the denominator is equal to 0, but an e term, e to any power, could never be 0, so we don't have to worry about that. So then these are our only two critical numbers. And to find the intervals of increase and decrease, we're going to use the first derivative test and just put those on a number line. So we have 0 and 2/3. And we just need to test values into the derivative to see if it's positive or negative, because we know if the derivative is positive, that means our function's increasing, and vice versa for negative and decreasing. Now when we test these numbers, we really don't have to worry about the denominator because e to the 3x is always positive anyway. So if we plug in a negative number, so this is going to be negative, but this is going to be positive because any negative number here is going to turn that into a plus. So this is minus. Anything in between 0 and 2/3, this is clearly going to be positive because now this is a positive number. And if this is a very small fraction, then the 2 is going to win, and that's positive. If we plug in anything bigger than 2/3, like let's say 1, this is positive and this is negative. So we get negative. So here's our first derivative sign chart. And we want to find the intervals of increasing and decreasing. So we would say that this function is increasing only on the interval between 0 and 2/3. It's decreasing everywhere else, which is negative infinity to 0 and 2/3 to infinity. So those are our intervals of increase and decrease, and our critical numbers were both just 0 and 2/3.
The Teaching Center, UF's Learning Resource Center.